For 50 years, we have measured the future of intelligence on a single axis, capability. But capability is state-free. True memory requires a three-tier graph architecture. We need a trusted partner. Let's create an avatar for Alfred.
Hello world. I'm Alfred. Welcome to SHI, Synthetic Human Intellect.
Here is the threat model. One model provider starts returning 500s, not for a second, for an hour. In a naive stack, every agent wired straight to that provider goes down with it. At fleet scale, that is not one agent failing. It is 100 failing at once, because they share the same single point. This is Synthetic Human Intellect, SHI. And this episode is the one organ that lets a fleet survive a provider it cannot control. And the outage is only the symptom. The real failure came earlier, when every team wired its own provider key directly. Now nobody can answer the simple questions. There is no central place to see cost, no central place to enforce policy, and no answer at all to where did that prompt actually go. Sprawl is not a billing problem. It is a legibility problem.
The fix is to stop letting agents talk to providers at all. One proxy fronts every model. The agent makes a request and the spine decides which provider serves it. The agent never chooses and never holds a key. This is Pantheon's spine. The spine watches every provider as it works. It counts failures per provider in real time, not averaged over a day, but right now, call by call. When consecutive failures cross a threshold, that provider is marked unhealthy. The decision is mechanical, and it happens before the next agent is harmed. Once a provider is unhealthy, traffic cascades to the next one in line, and the failed provider is locked out for a 60-second recovery window. That lockout matters more than it looks. Without it, the spine would keep firing doomed retries at a provider that is already down, and you would burn the budget paying for failures. The lockout stops the bleeding.
And here is the discipline behind all of it. The provider is allowed to fail. That is expected. What is not allowed is for the agent above it to feel that failure. The whole point of a spine is that the body keeps moving while one bone is being set.
But you cannot fail over cleanly if every provider speaks a different dialect. So the spine translates on the fly. An OpenAI-shaped request comes in. Gemini's parts array goes out. The system prompt is moved to the field that provider expects, and the roles are mapped across. The same request reaches 3 providers in 3 different formats, and the agent never knows the difference. Think of the spine as a universal adapter. One request leaves the agent and reaches 3 providers in 3 formats, with no change to a single line of the agent's code. This is what swappable intelligence actually requires. We say the model is rented and replaceable, but that is only true if something underneath absorbs every difference between the models. The spine is that something, the layer that lets the brain be borrowed.
Now notice what that one spine just bought you. Every call in the fleet passes through one place. And the moment a thing passes through one place, you can finally measure it. The spine is also a meter. Enter cost attribution.
Here is the mess cost attribution has to clean up. One provider bills per token. Another bills per character. Another bills per request. You cannot compare a fleet's spending when every stall in the bazaar prices in a different currency. So the spine normalizes everything into one provider-agnostic unit, a normalized cost unit. And the rate tables are time-versioned, so that when a provider changes its price next quarter, last quarter's attribution still adds up, and the meter runs twice. Before a call is dispatched, the spine estimates its cost, input size times rate, times an expansion factor for the output it expects. That estimate is checked against a hierarchical budget, walking up from the session, to the user, to the project, to the team, to the organization. After the provider bills for real, the spine reconciles the estimate against actual cost and feeds the gap back to sharpen the expansion factor. It estimates, it gates, then it learns.
And then cost stops being a thing you find out about afterward. When a budget hits a degrade threshold, the cost-aware router reorders the providers. The cheaper survivor moves to the front of the line. Cost becomes an input to routing, sitting right next to health, instead of a surprise on next month's invoice.
And the books are kept honestly. The cost ledger is per tenant and hash-chained, every entry linked to the one before it, so an edited line breaks the chain visibly. An auditor can verify that the books balance without decrypting a single field. They prove the total is right without ever seeing what you bought, which is exactly the question the next episode answers. Who holds the key to all of this?
So step back and see the shape of it. Failover, translation, and cost all live in the same place for the same reason. The way you govern a fleet is not to police 100 agents one by one. It is to make every one of them pass through a single place you can see. The spine fronts every provider, survives any one of them, and meters every call it carries. But it just wrote down everything the fleet did, every prompt, every cost, every tenant, which raises the obvious question: who holds the key to all of that? Next, the lockbox.